Welcome to the 4th grade math channel of Sun Devil Learning Labs. My name is Miss Houston, and today we're going to be working on subtraction with the standard algorithm. This is very similar to what we've been working on this week, except instead of addition, we're going to be switching it over to subtraction. So, our objective for today, you guys can go ahead and say this with me. I can subtract using the standard algorithm and apply this knowledge to word problems. And the only materials you're going to need are just a piece of paper, pencil, and an eraser. That way you can do your work on your paper while I'm doing it on the video screen here. So first off, we're going to practice subtraction with the standard algorithm. Just like we did with addition, we're going to practice with the place value chart and the standard algorithm side by side. That way you guys can see why we're doing what we're doing, how we're doing it, and what we're doing exactly. So what we're going to do, our first problem is 1,989 minus 532. And as you guys can see at the bottom here, I have our tape diagram. So for, one slide back. So for our tape diagram, we have 532 on the bottom, and then we have a question mark as the other side of it. The entire bar here is in 1,989. If we have 532 parts of that, we want to figure out what the other part is in order to make 1,989. That's why we're looking at this as a subtraction problem, because we know one part and we know the whole, but we're missing one of the other parts. So what we're going to do, first thing is we're going to fill out our place value map. So I'm going to grab my little stamp tool, and you guys can go ahead and draw a place value map on your piece of paper. You're going to have the thousands column, hundreds column, tens column, and a ones column. Go ahead, draw that. If you need a little extra time, go ahead and pause the video. If not, just go ahead and keep going with me. So 1,989. We have 1 in the thousands place. In our hundreds place, we have 9. So I'm going to put 9 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9. In our tens place, we have 8. And then in our ones place is right here, we have a 9. So I'm going to put 9 X's here. Perfect. So our number 1,989 has been demonstrated in our place value map. So now what we're going to do is we're going to put the number 532 in. So for 532, I'm going to represent this using a little green check mark. So in our thousands place, we have nothing. So I'm not going to put anything in my thousands place in the diagram. In our hundreds place, we have a 5 though. So I'm going to put 5 check marks. And then in our tens place, we have 3. So I'm going to put 3. And then in our ones place, we have 2. So what we're doing, since this is a subtraction problem, instead of adding up the total number of stamps we have in each column, we're going to take the red stamps minus the green stamps. So what I'm going to do is I'm just going to draw a little subtraction sign. That way we remember that we're subtracting this entire time. Just like that. So if we have in our first column, let's look at our ones column together. If we have 9 X's and then 2 check marks, what's 9 minus 2? 9 minus 2 is 7, right? That means that we're going to have 7 in this column, because essentially these check marks mean we're taking away 2 of these X's. So we're just going to write a 7 in our ones place. Now let's look at our standard algorithm. 9 minus 2 is 7, right? So we're going to put a 7 in my ones place here. Now let's look at our tens column. In our tens column, we have 8 of the X's and we have 3 check marks. So we're going to take 8 minus 3, because we're taking away 3 of those X's. So we're going to have 5 left over, right? So I'm writing a 5 here, and that's going to be our tens digit. Now if we look over at the standard algorithm, we have 8 minus 3. 8 minus 3 is 5, right? So I'm going to write a 5. Now let's look at our hundreds column. In our hundreds column, we have 9 X's and 5 check marks. So 9 minus 5 is 4. So I'm going to write 4 here. And we're going to circle that. And I'm going to write a 4 in my column right here. And then in our thousands column, we have 1 minus nothing, right? 1 minus 0 is still 1. So we're just going to bring this 1 down. And then we got to make sure we have our comma. Our comma goes right there. Oh, sorry, we need to put a 1 here. So we need a comma 3 digits from the right. As you guys can see, 1 minus nothing still is 1. So if we look at our place value mat versus our standard algorithm, we have the number 1,457 and the number 1,457. Ta-da! Same answer. So that means that 1,989 minus 532 equals 1,457. Now, if we look at our bar diagram at the bottom here, we wanted to figure out what that other part of this whole was. If we knew what 532 was one of the parts, we just determined that our second part is 1,457, right? Because 1,457 plus 532 is going to give us our whole number of 1,989. Fantastic. So now let's move on and try another one together. So for this one, we have 2,125 minus 1,009. So we're going to start off with our place value mat. Let's put the number 2,125 in. So we're going to put X's. We have 2 thousands, 1 100, 2 tens, and 5 ones. Awesome. Now let's look in our thousands place. So our the 1,009 number. I'm going to use check marks to demonstrate this. So we have 1,000, 0 hundreds, 0 tens, but we have 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Now let's start doing the math. Let's start in our ones column. So what we're saying right here is essentially 5 minus 9. Well, 5 minus 9, we can't do that, right? Because 5 minus 9, we just can't do that and have a whole positive number left. Like, it just doesn't make sense. So I'm going to tell you guys a trick. What we're going to do is if we look at our tens column right here, see how we have this X here? Remember, 110 is equivalent to 10 ones. So I'm going to take this and I'm going to trade this bundle down for 10 extra ones. So I'm going to draw 10 more X's here. So we're going to get my stamp tool and I'm going to draw 10 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what we're going to do is this number is no longer in the tens column because it's been moved over to our ones. So now what we're saying is we have 15 X's minus 9 check marks. So what's 15 minus 9, guys? It's 6, right? Perfect. So I'm going to write a 6 in my ones place, and that is going to be our ones answer. Now, if we look over at our standard algorithm, we're going to see we have the same problem. 5 minus 9. 5 minus 9, once again, can't do that, right? So we're going to look in the tens column, which is the column to the left, and we're going to borrow out one set of tens and turn it into 10 sets of 1. So I'm going to show you guys how that's done. So what we're going to do is I'm going to take this, we're going to cross our 2 out, and we're going to make this a 1. Because we're taking one of those away. So 2 minus 1 is 1. And then we're going to cross the 5 out, and we're going to make it a 15 because we're adding 10 ones to it. 5 plus 10 is 15. As you can see, when we had our 5 stamps here, it turned into 15 stamps. And these 2 tens turned into 1 10. That's how the two methods correspond with each other. So 15 minus 9 is 6. So I'm going to write a 6 right there. Now let's look in our ones place. In our ones place, we only have one X and we have no check marks to get rid of. So I'm just going to write a 1 in my tens. Then if we look over here with our standard algorithm, 1 minus 0 is still 1. Now let's look in our hundreds. Oh, same situation, right? Only one X, no check marks. So 1 minus nothing is 1. I'm going to write a 1. 1 minus 0 is 1. And then we need our comma because we have 3 digits. And put a comma here. Next up, in our thousands place, we have 2 X's minus 1 check mark. So we're saying 2 minus 1. 2 minus 1 equals 1, right? Perfect. And then if we look over at our standard algorithm, 2 minus 1 equals 1. So our answer for this is 1,116. And the way you can check your work is by doing 1,009 plus 1,116, and your answer will be 2,125. The reason for this is because it's just like the bar diagram. You have your part, whole. and that's why all three numbers are related to one another. So what I would like you guys to do for our next problem is you're going to do this one on your own. You're going to take the standard algorithm and you're going to try to solve it. If you guys can do this without the place value mat, perfect. If not, don't worry about it. We're still learning and we're still working on this concept. So if you need to draw a place value mat on the side where you have your thousands, hundreds, tens, and ones, go for it. Whatever helps you to do it best. So what you're going to do is go ahead and pause the video and take some time and do this on your own. When you're done, return and we'll figure this out together. So go ahead and pause now. Perfect, guys. So let's go over the answer together now. If we're looking at the standard algorithm, let's start in our ones place. So I'm going to grab my pencil. We first have 2 minus 4. I can't do 2 minus 4, so I need to look into the column to the left, and I need to borrow out some numbers from there. So I'm going to take this 3. I'm going to cross my 3 out, and I'm going to write a 2, because we're taking one set of 10s away, and we're adding those 10s here. So 2 plus 10 is 12, just like that. So now we have 12 minus 4. What's 12 minus 4? 8. So I'm going to type in my 8. Oops. Just like that. Next up, 2 minus 3. I can't do that. So now I'm going to go over another column to the left, and I'm going to borrow some more numbers from there. So we're going to take this 9, we're going to cross it out, and we're going to make it an 8. We're taking one of the 10s away. And then we're going to take this 2, and turn it into a 12, because we added those 10s to that 2. So what's 12 minus 3? 12 minus 3 is 9. Now let's try the next column, our hundreds column. 8 minus 7 is 1, right? Now we need a comma because we have 3 digits. So we're going to put our comma here. Next up, what's 8 minus 0? 8 minus 0 is still 8. So I'm going to write an 8 right in the thousands place. And then for our next one, 1 minus 1 is 0, right? But we don't need to write 0 because it's nothing. So we're just going to leave it since there are no other digits in front of it. So our answer for 18,932 minus 10,734 is simply 8,198. Perfect job, guys. So let's move on now. You guys did an amazing job working on that on your own. So for our next slide, we're going to work on a word problem here. For this word problem, I'd like you guys to solve this with me, and then you're going to do one on your own. So we have, the mayor plans to celebrate 4th of July with a fireworks show. This year, he is expecting 22,152 people to come. Last year, only 19,761 attended. How many more people does he anticipate to come this year than came last year? So if we're looking at this, we have these two numbers, and we need to figure out what to do with them. We're going to be subtracting them, right? Because if we have 22,000 and 19,000, he wants to find the difference between those. So we're going to take the bigger number, and we're going to put a minus sign, and then we're going to put the little number underneath it. Because that is how we're going to subtract them, and we're going to find the difference. So if we look at the standard algorithm I have over here, let's solve it. 2 minus 1 is going to be 2. So we're going to write a 2 in our ones place. 5 minus 6. Can't do that, right? So we're going to go over to our hundreds place, and we're going to borrow from that. We're going to take this 1, and we're going to turn it into a 0. And this 5 is going to become a 15. Because we moved that bundle of 10 over to the right instead of keeping it where it was. So 15 minus 6 equals 9. So I'm going to draw a 9 right here. And then we have 0 minus 7. Can't do that, right? So I'm going to borrow from the other column. I'm going to take this 2 and we're going to turn it into a 1. And this 0 is going to become a 10. Next up, 10 minus 7 is 3. So I'm going to write a 3 in my hundreds column. And then we have 1 minus 9. Can't do that. You know what, though? We can keep on borrowing, so we still have places to go over. So if we take my pencil, I'm going to take 2. I'm going to turn this 2 into a 1. And then this 1 over here is going to be turned into an 11 because we added 10 to it. So 11 minus 9 is 2. So I'm going to type in our 2. And then since we have 3 commas, we need to make sure, 3 digits, we need to make sure we have a comma right there. Next up, 1 minus 1. What's minus 1? Or 1 minus 1? It's 0, right? So we're just going to leave it. We're not going to write anything in that column. So our answer is 2,392. Oh, 2,392 what? If we look back at our word problem, the mayor plans to celebrate 4th of July with a fireworks show. This year, he's expecting 22,152 people to come. Last year, only 19,761 attended. So, how many more people does he anticipate to come this year than came last year? If we're trying to answer this, we're trying to figure out how many more people are coming this year than arrived last year. So our answer is going to be 2,392 more people. This is the label that we're going to use, and this is how we're going to answer our question. So that way the person that's reading this, they know exactly what we're talking about. And we're not just talking about a number. We're talking about a certain number of people. So perfect. We solved this question, and now what I would like you guys to do is I would like you to do the next column on your own, and then when you're done, you're going to pause it, and then we're going to go over the answers together. So go ahead and pause now. Now that you guys have solved this on your own, we're going to go over the answers together. Our question asks, Joe is driving to his aunt's house to celebrate the 4th of July. His aunt lives 13,456 miles away. If Joe drove 10,987 miles already, how far does he have left to drive? So this is going to be a subtraction problem because we want to find the difference of how much more miles he has to go. So what we're going to do is when we're subtracting, we always want the bigger number on top and the little number on bottom, right? So looking at this problem, our bigger number is 13,456. So I'm going to type in that. And then what we're going to do is we're going to subtract from this 10,798. Just like so. Oops, sorry guys, we got to go back one. So if we have our problem here, we are subtracting, right? So I'm going to put a little subtraction sign. And we want to figure out what our answer is from this. So looking at this, let's start in our ones place. We have a 6 and an 8. Well, we can't have 6 minus 8, so we need to borrow over from our tens place. So I'm going to cross out my 5, and I'm going to write a 4. And I'm going to cross out my 6, and I'm going to write 16. What's 16 minus 8? 8. Next up, let's look at our tens place. 4 minus 9. Uh-oh, I can't do that. So I'm going to take the 4, turn it into a 3, and then this 4 becomes a 14. What's 14 minus 9? 5, right? I'm going to write a 5. And then how about 3 minus 7? I can't do that again. So now we're going to borrow once again from the place to be left. I'm going to take 3. This 3 becomes a 2, and this one becomes a 13. So 13 minus 7. 6, right? So I'm going to write a 6. And then if we're looking at our our thousands place, we have 2 minus 0. 2 minus 0 is still 2. And then we need a comma because we need a comma since there are 3 digits starting from the right. We need to put our comma there in order to distinguish our thousands from our hundreds and the rest of the place values. And then 1 minus 1. 1 minus 1 is nothing, right? So we don't need to put any answer there for that. So we now have our answer, 2,658. But 2,658 what? Looking at our problem, let's see. We are subtracting miles from miles, right? 13,456 miles from 10,798 miles. So we are going to say that Joe has 2,658 miles left to drive. And we want to make sure we have our label like this. That way the reader or whoever is trying to figure out the answer to the problem, they know exactly what we're talking about. We're not talking about 2,658 cookies or cars or houses. We're talking about miles here, and that's an important distinction to make. Let's move on to our discussion question for today. Why is the standard algorithm an efficient method for subtraction? Well, that's a really good question. So what we want to do is we've done questions where we have the place value mat and the standard algorithm side by side. And then we've done questions where it's just the algorithm. So what's the benefit of that? Go ahead and pause the video for a second and talk with a partner, and then come back when you're done. Perfect. So now that you guys have talked with a partner, we're also going to talk about some other reasons why it can be more efficient. So for example, the standard algorithm takes a lot less time than the place value mat does. Also, it takes up less space. With the place value mat, you have to draw out your table, and then you got to put your little marks inside of it and then subtract. With the standard algorithm, all you have to do is just cross out numbers, rewrite numbers, and subtract down. So it's a little bit faster and it takes up less space. So our overview for today, our objective, and you guys can go ahead and say this with me. I can subtract using the standard algorithm and apply this knowledge to word problems. We did this today. You guys did an amazing job learning, and I hope you liked the theme of this lesson today. It was 4th of July theme, since 4th of July is right around the corner. Anyways, I hope that you guys all have a super great day.